This is the start of 1.2, Memory and Storage. In this lesson we're going to look at primary storage, also called memory. The key questions in this lesson are: what is the purpose of primary storage, and can you explain the differences between primary storage and their uses? Here's the keyword wall for this lesson. You're going to have to know and be able to explain all these keywords. Task number 1 is a recall task. Please open your new student workbook and then drag the ticks and the crosses into the correct places. Pause the video and then I'll show the answers shortly. There's also an extension activity at the bottom of the page. Here are the answers. The CPU doesn't stand for the Computer Professional Unit, so that was false. Number 2 was correct. It's sometimes referred to as the brain of the computer. Number 3, it doesn't use fetch, decode and evaluate instructions. It uses fetch, decode and execute instructions. Number 4, the speed of the CPU is measured in hertz, so that was correct. Hertz is sometimes abbreviated to HZ with a capital H. And number 5, the CPU is found on the motherboard, which is true. So what is storage? I want you to find the page that you can see in the top right hand corner of this slide, and you're going to have to explain what storage is. So, storage is the ability for computers to remember data, and sometimes we actually call that memory, particularly when we're talking about primary storage. We'll look at the difference between primary storage and secondary storage shortly. Now, memory is where we save data as zeros and ones, and you might remember this as binary. We know there are several devices in a modern computer and several ways that data can be stored. Computers store data in different ways and for different purposes, and we're going to have a look at some of these. Now let's have a look at the two different types of storage. First of all, primary storage is RAM and ROM. We can find this inside the computer, usually attached to the motherboard. Secondary storage is storage which is outside of our computer, such as USBs, CDs, DVDs and memory cards. We're now going to take a look a bit deeper at the differences between primary and secondary storage. You'll find a page in your workbook called Primary and Secondary Storage where you need to put key definitions into these boxes. So primary storage is known as main memory, sometimes can be called internal memory. It stores the computer programs whilst they are running and any data which is needed for those programs to undertake their tasks. However, it is volatile, such as RAM, random access memory. Volatile means that data is deleted when the computer is turned off. There is another type of primary storage called ROM, and this is actually not volatile, so it's not going to be deleted when the computer is turned off. ROM will store the BIOS, or the boot sequence for our computer, so the instructions that are needed to turn the computer on and to load the operating system into RAM from the hard drive. But we'll look at this in more depth in a future lesson. Our secondary storage is storage which is outside of the computer, and these are devices which are used to store files and data which you have finished working on, so that when you turn the computer off you can use them in the future, and you'll recognise these. These are USB drives, hard drives and anything else you might store data on. Your next task. Once you've given me definitions of primary and secondary storage, please go back through your definitions and highlight in a different colour any key words. To help us remember the different definitions, I want you to complete this page in your workbook. Find images of primary storage and secondary storage. If you manage to do that, there is a third type of storage which isn't included in this specification but is quite interesting to find out about. That is tertiary storage. There's a link for you to click on and to find out a little bit more information. So I want us to think about why we actually need two types of storage. On this slide we should have some animation with some questions. Please try and answer the questions. So if we look at the diagram, you'll see a large hard drive. A hard drive is connected to the motherboard, which is the big green item in the centre, through a series of wires. RAM is actually located directly on the motherboard, and you can see two black long connection points on the right hand side of the motherboard where the RAM would go. So we find primary storage on the motherboard. It's close to the CPU. You can see the distance, it's not far at all. Whereas for data to get to the hard disk, it's got to go through a wire. That means RAM is much closer on the motherboard. Imagine it like this. You're going to have to go and collect something from a friend. Would you rather go to Blackpool, or would you rather go and have to collect the information from Spain? Well, we'd probably all say Spain because obviously we'd like to go on holiday. But if we're thinking about speed, there's a massive difference here. Driving all the way to Blackpool is much quicker than getting a plane to Spain. And we can think about primary storage as being close, and secondary storage is a long way away. Every time we have to go to secondary storage, it's going to take us a long time to go and get that data. Whereas if we can get data from RAM, it's much closer. It's going to be much quicker. So RAM and primary storage is fast. It's much quicker to retrieve that data than secondary storage. So you may be asking, well, why don't we just store everything in RAM? What is the point of secondary storage? Well, the problem with RAM is that it's volatile, and that means it's deleted when you turn the computer off. It needs power to work. So we need something to store data in permanently. And that is where we use secondary storage. When you click Save, it's going to move your data from RAM, what you're currently working on, into our secondary storage. So when you tell a teacher it didn't save, that's because you haven't saved your work to secondary storage and you haven't clicked Save. I want you to go and find this page in your workbooks and try and give me a definition of what volatile is. Pause this video and complete your definition. So volatile. Volatile means data that is lost when the computer is switched off, because the memory or storage would need power. And this is the opposite to non-volatile, which means that data isn't lost when we turn off a computer. RAM is volatile, whereas USBs, hard drives and secondary storage is non-volatile. So what does RAM stand for? It stands for Random Access Memory. Let's have a closer look at what RAM actually is. So when we load a program, and I've given you some examples of programs on the screen, including operating systems, we need to load those into RAM. Remember, this data is removed because it's volatile when we turn off the computer. But we're moving it closer to the CPU so we can access the instructions from those programs quickly. It's a much faster rate than if we were having to access them from secondary storage. We might be running several programs at the same time, and we want to get hold of that data quickly. To be able to run multiple programs at the same time, RAM helps us multitask. We can have several programs open, all stored in RAM. It stores all the instructions from those programs and all the data when they are open, when they are running, and the computer is on. Please complete this slide. What is the purpose of RAM? You might want to watch back the last part of the video and listen to my explanation of RAM and make sure you've included all the information. So remember that RAM is much closer to the CPU. That makes it a massive advantage. However, compared to secondary storage, RAM is quite small. An average size of RAM would be 8 gigabytes, whereas you're going to get much larger secondary storage, and some hard drives can be terabytes in size. I've represented this in a diagram on this slide. Each red box or square is worth 1 gigabyte. And you can see that we've then got 8 slots for RAM, and we've got an awful lot more for our hard drive. Now remember that data in RAM is deleted when we turn it off, but let's start trying to run a few programs in RAM. Here I've opened Word on my computer, and the average size of Word is 250 megabytes. Now that doesn't look particularly large. I've put it into RAM, and you can see it takes up a small amount of that. But look at the difference it would be in our hard drive. It's a tiny, tiny amount. So remember, our secondary storage has more storage. Now we've got 2 processors running, we've opened Spotify. Spotify on average is 500 megabytes in size, and we've put that into RAM. And just to show you the size of it in comparison, I've put it into the hard drive. Now for multitasking, we can use RAM to store both Word and Spotify, and we could be listening to music whilst writing some essays or doing some homework. Both of those applications are close to memory. That means we can switch between them and we can keep processing that data. Remember, we wouldn't use secondary storage for these running data because it is a long way away. But when we've finished, we're going to move any data we want to store into secondary storage, and that's why you can see them in secondary storage. So we're using an operating system as well, Windows 10. It's about 2 gigabytes. So if I put the gigabytes into our RAM, you can see that we've used 3/10 of our RAM now. So as we start to load our RAM and load other programs, you'll see it start to fill. Imagine if your computer only had 4 gigabytes of RAM. We'd nearly have filled our RAM. So we need to store data in our hard drive once we turn it off, remember. And you can see that's saved over on our hard drive. Now when we load our operating system, not all the operating system is loaded into our RAM, only the parts we need. So you've seen some advantages and disadvantages of primary and secondary storage. I want you to complete an extended answer now to explain why both RAM and secondary storage are needed. I'm going to give you some hints for this. Here are your hints. RAM is volatile and secondary storage is non-volatile. Think about the size of the storage, which one's bigger, which one's smaller, and then think of the distance to the CPU. Pause the video and complete your answer. You should have completed your answer now. Please go back through it and make sure you've included the following points. RAM is volatile, whereas secondary storage is not. Volatile means that the data is lost when we turn off the computer. So even though RAM is closer to our CPU, we need to store our data sometimes when we turn our computer off in our secondary storage so that we don't lose it. It's important to have RAM though because we want to be able to access data quickly. And remember, RAM is holding the programs that we are currently using. So we need to get fast access to them. And RAM is on the motherboard. This makes it much quicker and much easier for us. However, secondary storage is much larger in size than RAM. And this will have massive advantages. And we're going to look at something called virtual memory in a future lesson, but that's going to have a big impact on our storage. You need to find this page in your workbook, and I'm going to go through the answers shortly, and I want you to add the important details into this slide. So you need to know that RAM stores data as small charges of electricity in tiny transistors. These transistors are etched into the circuit of the device. Please can you pause your video and find a picture of a transistor and add this onto your slide. Okay, so you should now know what a transistor looks like. Now these store the small charges of electricity. Now if it stores electricity, we can think of that as a 1. If it doesn't store electricity, we can think of that as a 0. Now this charge, which it stores, is refreshed every few milliseconds. Otherwise, that's going to leak away. And we use capacitors to hold that charge in place. That allows us to store our series of binary. This means because the charge is leaking away, it's volatile. So not only is memory volatile because when we turn the computer off it loses our data, the charge actually leaks away. So as I've said, we need to keep holding that charge. And that is the second part of being volatile. So please fill in that page about how does RAM work, and I want you to go back to the slide on volatile and just add that extra information about charge leaking away.